Good morning, guys. So just a quick lesson. As I told you, we're going to go over translations today. So we want to first look at that standard, and we are doing math, Georgia Standards of Excellence, 8th grade, geometry, first standard. Remember, geometry is 28% of your milestones. And this is where we had to verify experimentally the congruent properties of rotations, reflections, and translations. And of course, today we are just looking at translations. So lines are taken to lines and line segments to line segments of the same length. Angles are taken to angles of the same measure, and parallel lines are taken to parallel lines. So when we do a translation, you are going to, your pre-image and your image will be the same shape and the same size. Okay, remember these are rigid transformations, so it doesn't change the shape or size. But even with a translation, it doesn't change the orientation, meaning it's not going to turn or flip. The images, literally all the points are still going to be in the same place. So your essential questions today are: how can the coordinate plane help me understand properties of reflections, translations, and rotations? And again, we're looking at translations today. And your next essential question: how can I perform translations on the coordinate grid? So let's go through. Let's first look at the coordinate grid. Now, it does not matter if your coordinate grid has numbers or not. Notice this one has numbers and then this one does not. Does not matter. So on the coordinate grid, let's talk about a few things. So if you move up or right, so if you go up on the y-axis or if you go right on the x-axis, those are positive moves. So you would add those in. And it doesn't matter if you start over here in the negative section and, oh, why is you doing this? It doesn't matter if you start on the negative side. If you move right, your coordinate, your x-coordinate might still be negative. It's still a positive move. Okay, so if you go down and left, those would be negative moves. If you go down on the y-axis or left on the x-axis, it's going to be a negative move. You would subtract the number of units that you moved, and we are going to look further into that. I want you to have this to go back and review. So let's look at the coordinates, because sometimes those can help you with understanding what your coordinate might be. So when I go through in this section, remember we start in quadrant 1, and remember your quadrant moves, they move counterclockwise. The quadrants on the coordinate plane, they move counterclockwise, so kind of opposite of a clock. And let's look at what those would be. So if you're in the first quadrant, you're going to have a positive x and a positive y. Remember, I don't have to put the positive sign there. We're in 8th grade. We should automatically know if there's no sign, it's a positive number. Now, if I move over to quadrant 2, I'm going to have a negative x, but my y is still positive because it is above the origin. Okay, it is above that origin. So when I move over to quadrant 3, now, from the origin, I have gone left and I also went down. So those coordinates are going to both be negative. And I want you to look at how this is the opposite, like 1 is the opposite of quadrant 3. Okay, those are opposites. Now, if I go over to quadrant 4, now I have moved right of the origin, but I still went down from the origin. And notice that these are also going to be opposite of each other. So if you understand what the signs are going to be in the quadrants, that will also help in understanding the translations. All right, so let's look at this particular one. We talked about in translations that every point has to move the same distance and the same direction. Okay, so you'll notice that every point on here is moving down 3 units and right 4 units, every single point. So this translation, and we use a capital T to represent translation, each point went down 3 units, and well, let me write that the other way, guys. So when I'm doing this, we got to be mindful that we use x first, okay? So on this, each point went 4 right, but then we went 3 down. That means every x coordinate you're adding 4, and every y coordinate you are subtracting 3. All right? And so if we look at these two particular shapes, some of them are just going to be a slide where it just shifts to one place. So if I look on this one, 1, 2, 3, 4, 5, 6, 7. Every point on here should move 7 spaces. 1, 2, 3, 4, 5, 6, 7. And look how I'm counting. When I hit the x-axis, I am counting that. Let me swap colors here. So I've got 1, 2, 3, 4, 5, 6, 7. So on this particular one, over here, the translation here, they moved right 6, so that was positive, but look, they didn't move up or down, so we're not going to add or subtract anything from that y coordinate. Now, if we look at this one, it's a little bit different. On this particular one, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So they went right 9, and they went up 1, 2, 3, 4. Okay, and each one of your points should do that. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, it did the same thing. We went right 9 and we went up 4. And you can check all of your points to see that they've done that. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so again, we went up 4 and we went right 9. And yes, I am marking all these. You want to check to make sure. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. So again, right 9, up 4. So for this particular translation, and remember, if you see a capital T, that means you're about to translate something. So on this particular translation, we went 9 right, meaning we're going to add 9 units to every x coordinate, and we also went up 4. So we are going to add 4 units to each y coordinate. All right, so what I want you guys to do is you will look at the one on the screen. I'm going to pause it, and I want you to go through and tell me how your pre-image, and I know this is my pre-image because it doesn't have the little ticks beside it. So we're going from this pre-image to the image. So I want you guys to tell me, and then we're going to go over it in class. So good luck, guys. Easiest one, we're going to knock it out.